let's move on to the next question. Question number 4. They are asking you which of the following has one subset. What is a subset? If I say A is a subset of B, then for every element which belongs to A, it implies that it also belongs to B. Every element of A is also an element of B. Now we are asking you which of the following has only one subset. We know that if there is any set which has n elements, if I say number of A in A is n, then there would be how many subsets for the given set? 2 to the power n. Here we are saying that 2 to the power n is equal to 1, which implies that n is equal to 0. When can I say there is 0 number of elements in a set? When the set itself is an empty set. So according to the given conditions, I can say that option A is the correct answer. Alright, let's move on to the next question. The next question is, we have been given some sets. Set A is 1, 2, 3, 4. Set B is set of prime numbers. If I want to list out the elements, then it would be 2, 3, 5, 7, 11, 13 and so on, as we know that the set of prime numbers will have infinite elements. Set C is set of positive odd numbers. That means 1, 3, 5, 7, 9 and it also goes on, as the set of odd numbers would have infinite elements. Now they are asking you which out of the 4 options could be the universal set L. What does it mean to be a universal set? When I am saying that L is a universal set, it means that all the subset possible from set A, B and C should be present in set L. Or else I can say that if I am talking about here a particular type of numbers, elements of set A and B and C has to be present in universal set L. So I can take all the union of A, B and C and I would get 1, 2, 3, 4, 5, 7, 9, 11, 13 and so on. If I can make any subset of A, B, C from L, L is our universal set. If you take a look here, I can take any subset and that would be possible to make out of L as well. What do I mean? If I want to take any subset of A, that is 1, 2, 3, then I can take 1, 2, 3 from the set L and that subset would be possible to make from set L as well. So I can say that a set which contains all of these elements is our universal set. Now but the option does not have this answer. So how to figure out what is the correct answer? We can see that 1, 2, 3, 4, 5, 7, 9, 11, 13, all of those are positive numbers, or should I say natural numbers. And in the option we have a natural number. If these are the elements I want in a universal set, then L would be our universal set, but we clearly know L is a subset of N. So I can also call N as a universal set for the given sets. We know that N is a subset of Z, so I can also call integer set as a subset. Integer set as a universal set. And now here we have R. R is the larger set. It contains natural numbers, integers, rational numbers, everything. So if L is the bare minimum condition for a set to be a universal set and it is a subset of natural number, I can call natural number as our universal set. Natural number is a subset of integer, so I can call it as our universal set. Integer is a subset of real numbers, I can call it as a universal set as well. So I can see that N, Z and R, all the 3 sets could be the universal set. That means that all of this are the correct answer. That means option D. I hope you understood how all of these are the correct answer. Alright, let's move on to the next one. Here they are asking you to find A minus B minus C. Here in the given question we have set A as 1, 2, 3, 4. Set B as 3, 4, 5. And set C as 4, 5, 7, 8. Out of all of it, they have asked us to figure out what could be the correct answer for this operation, A minus B and then minus C. If I see, I have to first conduct A minus B. What does it mean? I have to collect the elements X such that X should belongs to A and X should not belong to B. If I take a look at set A and set B, I can say 1 and 2 are the elements which belongs to set A but not to set B. And now if I do A minus B minus C, that means that I have to take X such that X should belongs to A minus B but X should not belongs to set C. Again, if we take a look, set A minus B has 1 and 2, set C has 4, 5, 7, 8. If I take a look, 1 and 2 are the elements which are present in A minus B and not C. So the final answer for this would be option D.